Okay, good morning, everyone. Let's get it started and maybe slowly, so the others will still join us. So this is the last lecture for the course Cartographic Visualization GIS. Crazy how time flies. Yeah, today we have very practical things. As you can tell from the topic, it's a bit of different beats that we're doing there. So we wanted to still cover as part of this course. And we have very practical things. During this course, we have learned how to design a map, and we have been practicing how to make a map. We are going to continue practicing in the remaining exercise and the final project. But last beats left, especially related to how to export map and some practical things that we will cover. Okay, so this is the overall structure of our talk for today, this morning. So I will briefly talk about non-cartographic visualization of geospatial data. You saw the idea already in your last exercise. Briefly going through that again. And then we focus a bit on the map design and roughly dividing maps into two categories of the static maps and interactive maps. We have already been making static maps previously, and also in this course during the exercises, but this week we are going to work with interactive maps, so this is what the practical part of this week's lesson will be about. We will be working with interactive maps. So we will talk about design matters specific to static and interactive maps today. And then we will briefly talk about cartographers inventory, briefly reviewing some of the tools that you need in order to become a good cartographer. And then we will briefly talk about data classification. It's something that probably have learned in your other courses, but since this came up in exercises, I thought if we have time today, we can briefly look at that. And then discussing a little bit about the role of AI in cartography, having a bit of discussion about that. And then if we have time at the end, we will talk about the portfolios, what you will be doing as the final output of your for this course. So if we have time, we will go through that. If not, we will continue more in the afternoon discussion session. But yeah, so you already saw this picture. I talked about this already in the tutorial last week, but non-cartographic visualization of geospatial data, that's a thing. So, well, this is a course in cartography, so we have been highlighting the role of maps in understanding geospatial data, and there is definitely maps are the most powerful way how we can visualize geospatial data. But one thing to keep in mind and be a bit open-minded about is that making maps is not always the only way to visualize geospatial data. So the fact that you have been given a GIS data set doesn't mean that you have to immediately produce a map. So you should always ask yourself the question that, okay, what is it about this data set that I want to explore and visualize? And then map might be the way to go, very often it is, or sometimes you need to have other kinds of visualizations or complement your map with some other form of visualization. So this is something to keep in mind in your work and also in the final portfolio you're creating, because you're working with a bigger data set, so there are probably many aspects of the data that you want to explore. And a map may not be enough, so you may want to explore different ways of visualizing different aspects of your data. So there are a number of reasons why you may want to consider non-cartographic ways of visualizing geospatial data. One reason can be for simplifying very complex data sets. If you have very complicated data and you want to visualize it, finding a very simple way of visualizing that it might be a bit challenging. Sometimes you can tell say the same message, convey the same information using, for example, some kind of chart. If you think for your reader, the user of your visualization, it is easier to just look at a map, look at a chart instead of a map based on the information you want to visualize, then why not try that? For emphasizing connections, of course, in a map, you have a very good way of seeing two special connections. sometimes you can use different kinds of non-cartographic visualizations to highlight certain kinds of connections. So if that's the way with your data, then you should give it a try. And facilitating comparison. With charts, as one form of non-cartographic visualization, you can easily compare data. So if you have a bar chart, if you have a line chart, you can easily add several lines. And it's for a reader, for the user of your visualization, it's quite easy to compare that compared to producing several big maps and then putting them on one page. It can become complicated. So if there is a way to visualize it more efficiently without a map, then you should consider that. So there are many ways you can think of how you can visualize geospatial data non-cartographically. Of course, the most obvious choices are usually charts and graphs, different kinds of charts and graphs, bar charts, time series, line graphs. And in this week's tutorial, the practical part, we are going to learn how to create these Python. So we will use the Python library Plotly that we haven't worked before, at least in our courses. And it's a very good library for producing this interactive visualization. Another thing you may consider for visualizing your data is different kinds of infographics, combining text, images, and data. Depending on how you want things to be, how complex you want things to be, you may want to also, depends on the purpose of what you're doing, you might want to create some kind of a dashboard, integrating different kinds of interactive interfaces that combine multiple visualization tasks. This is, for example, something that they use in cities, like municipalities, for managing their data. They have this kind of GIS system, which very often provides a combination of cartographic and non-cartographic visualizations. And very often it is effective to combine various forms. So you might have a map. Since you have a geospatial data, very often it's hard to avoid that. We are learning cartography, so we want to make beautiful, informative maps. But at the same time, there might be aspects of your data that you may want to visualize with a chart, for instance. A combination of the two can be informative. So I have provided a link in this slide and also on the course's website to this article, which is actually there are a number of people involved, including Enrico and Tuuli from here, that you know. And they have very nice visualizations here. They have nice maps, but I also like especially how they combine the cartographic and non-cartographic elements. And to make the charts easy to use and connect with the maps, they use some kind of color coding. So the colors you see on the map, the link to the colors used in the charts, and that makes it very nice and easy to connect it to. Very often, not in this article, but you may have other kinds of multimedia that you may want to add to your visualization. So yeah, so that article is a good source if you want to get a good understanding of how you can explore your geospatial data also non-cartographically. But getting back to the main topic we want to explore today, so map media. So we have been going through the journey of starting from the raw data, and the end goal in this course, what we're doing here is to create a map. So there are different ways of how we want to go through this process. For example, last week we had the guest lecturer, Franz Mocznik, and he had his own way of going through this process. So this is a bit more technical compared to what he was presenting last week. The idea here is that, well, maps are powerful. I don't need to convince you anymore. We know maps are important, and the output here is maps. So we are starting from the data, and we want to create a map at the end. So knowing already from the beginning what form you're going to produce your map, what is the media that you're going to use for sharing the map with others, can kind of affect the path you want to take during the process. If you already know that you are going to print a map, it's good to know it at the beginning. So you might make certain decisions that are helpful for your final product. So roughly speaking, you start with raw data, and in this course we then do data analysis, but you know GIS, you know that when you get data, so you need to work with the data a bit. and then you have a more prepared data stored somewhere where you can easily use it. But then one way to go is your services. For example, that is often the case with like InfoShare of Helsinki region, many organizations. So they did produce these geoservices like WMS for raster or WFS for vector data, and they don't really bother with cartography. What they do, they just visualize it, so fetch the data and quite a quick visualization. But what we do usually is, unless you work in one of those organizations, what we do is this other path. So very rarely we just export the map. If you have a clean data you just want to quickly produce, which is not often the case unless you just want to quickly explore your data visually. But that's one thing. But very often we need to produce files, do GIS analysis, and take steps here, and then we are ready to export the map. One important thing, if you really want to make very nice looking maps, is to take that graphic software, which can come in different forms, a bit seriously. But now they are integrated in GIS software you use. So if you think of QGIS, you have that main window where you add things, you do your GIS analysis, you do different kinds of geoprocessing processes, and then you have this layout window where you just add the legend, you put a north arrow, you put a title, and then you export the map. You can think of that layout view as the graphic software, and it is. It's not really GIS that you're doing there. It's just doing a legend, dragging it here and there, copying and pasting. It's not really GIS. So it's an integrated graphic software, which is great. You can do many things. But there's limitations. So if you really want to make a beautiful map, there is so much you can do in QGIS, for instance. If you're comfortable with other graphic software, then you can use those to make your map nicer. For example, many cartographers use software such as Illustrator. It also works quite well with maps and spatial data. There are also many other open source software that you can consider using. So for that very beautiful, nice looking map, if that's the thing you're aiming for, this is very often needed. And then you either create a soft copy of your data, it can be a static or interactive. We'll talk about that later, or you will print the map as a hard copy, which will be static. So very often you have a choice, so you should think where you are going to use the map and what is the most suitable medium for sharing the map. So if you are having a workshop with people, it's about some urban topic, you're asking people's opinions, they're looking with maps, they're playing with things, then you might have the choice, should I print this map and put it on the table? And people who come to the workshop, they can work with the map, mark something. So, or you might have the choice of having a tablet where you can share the map with the participants digitally. So very often you have the choice. Should I print it or share it digitally? Should it be interactive or static? But sometimes, depending on what you're creating the map, you might be just forced to go with a certain medium. If you have been given the job to produce a map for HSL, if it is for metro stations, then they might want you to produce a version that is good for just printing. They want to print it, put it on the wall somewhere. So sometimes you don't have the choice, but if you have the choice, then you should think which one is the most suitable for you. So taking a different look at map making process. So first we start by doing some preparations, setting the objectives and the specifications for your map, defining what you want the map to visualize, what are the objectives, who's the audience, a lot of these things that we have previously talked about. Then we have the data collection and combination, as I said before, getting the right data for your work. Very often you already have the data when you want to start to make a map, and then working with it a bit to produce the visualization. And then it's the step of creating the map image. Create the map, do the visualization, and then you think, well, you already have thought earlier what is the medium you're going to use, and then you need to do some adaptation. So if you're going to use, this is a stage where you want to export the map. we are going to come back to this in more details. If you're going to export the map for printing, you should make decisions a bit differently compared to when you produce a map for a slide presentation or for your website. So that's something to take into consideration, and the distribution of your map in the right format. So again, we are going to talk a bit about formats today. So how are you going to distribute the map? Should you export it as a PDF, or should it be as an image? If it is an image, should it be a JPEG, or should it be a PNG? These decisions that affect the distribution of the map and its effectiveness. So let's just start with the static maps, and then we go through design details of static maps and interactive maps separately. So a lot of design things that I'm not going to repeat today are universal. So we have already talked about visual hierarchy, we talked about visual variables, color choice, symbols, and so on. So those are kind of universal. Of course, there might be considerations to make if you're having an interactive map, and generally the same rule applies. We have talked about colors, taking into account people who might be colorblind. So that applies to both, and we are not going to go through that again. These are more specific things about static or interactive maps. So what are static maps? I guess we all know they are fixed representations of geospatial data, meaning they do not change or allow interaction once they are created. They are typically produced in printed form or image files. So a number of considerations when it comes to static maps. So one thing is to know how it will be viewed. Is it going to be on a digital device or printed? So we are going to come back to this, but that's a very important consideration to take into account. If printed, will it be a large plotter or is it a paper? So if you're going to print it, is it going to be in your article, and the article is going to be printed on A4 paper? Or are you going to a conference and you have a poster or a bigger visualization? So that is one thing to think about. And depending on what your answer is to these questions, then you often face the question of like, what is a format? Because that is something we think about, and very often we just choose arbitrarily. So we just export it as JPEG or PNG without really thinking that, okay, what does this mean? So we are going to talk about this today a bit more. So one thing to demystify here is DPI, or dot per inch ratio. Very often we confuse this with resolution, which is not the case. So you need to think about DPI, or dot per inch, when exporting the map, specifically when you want to print the map. So it's a property of the printer how many dots it can print per inch on your map. So resolution refers to the dimensions of map in pixels. So the resolution is most relevant to think about when, of course, you're printing a map, but also when you have a digital representation. But DPI is what you should think about when you're exporting the map for printing. So a higher DPI results in more dots within each inch, producing a finer image if the resolution remains constant. But one thing that happens with increasing DPI is that the process of exporting can become longer. So if you make the DPI twice more, roughly the export time depends on many things, but the size of the file can become 4 times bigger. So it is often not a problem for us now. We have very good computers, but again, depending on the size, that might be something to think about. So export considerations: higher resolution files increase export time and file size exponentially, and the same thing with DPI. So if you increase it, the size gets larger and slower to produce. So again, think, if you're going to put the image and the map on your website, do you really need to have a very high DPI if you're not printing? Just making the file very slow to produce and also to load on your website. It's something to think about. Just click the default export button in QGIS or somewhere. So another thing the DPI is like determined by the device you're using for printing. So very often these cheap home inkjet printers, they do around 300 dpi. So if you produce a very large file, let's say 600 for printing at your home printer, that's just like unnecessary. It doesn't hurt, but it's unnecessary. But like better printers, like for example the ones that we have on campus, they probably can do like 600 dpi. So if you're going to use those, then you should go with 600. So if your printer is not capable of going with very high dpi, then producing a file with very high dpi is unnecessary. So we should take that into consideration. So exporting formats. So as I said today, the talk is like really practical. So very often we export our maps as image files. They're convenient, easy to use. You can just open it wherever. You can just paste it into Word or whatever word producer software you're using. But which one should you go with? JPEG or PNG or the other formats? So one thing you should, these are very common file formats, so very often many of us don't think about it, but we should. We should know that both of these file formats, which are very common, they are compression based. So when you export your map in QGIS or Python, anywhere, it applies that compression. And there's a big difference between these two formats, for instance. JPEG uses a lossy compression. So what it does, it lowers the quality of your data. So it has an algorithm when you export it. It resamples the data. It moves things around. It lowers the quality. It just lowers the quality. So very often you have noticed, and I have seen it in your exercises, when you export the image as JPEG and then put it in your map, some details are lost. So especially if you have very sharp edges or you have very small elements in your map, which is common in map, unless you're making this large map of continents or countries, you have those sharp lines. You have those small details. So you might have noticed that it gets very fuzzy. So I wouldn't recommend JPEG so much for producing maps but then it's very efficient. So if you really have a slow internet connection or you have a website which is very heavy, and for you it's important to have a fast enough file, then JPEG might be good. But one thing to take into consideration when using this file format is that most software allow you to adjust the level of compression. So probably you have seen when you export your map as JPEG in QGIS, it asks you, is it a quality or compression? How much compression do you want, or how much quality you want to preserve? So that is something to control. So if you want to go to JPEG, for example, because it's a smaller file, it's easier to put on your website, then find a balance, like how much compression you want. In software, it's usually some slider you use, and like if you're using, for example, Python, then there are parameters like in from matplotlib, so you can, of course, you specify the format you want, but also you can, with JPEG, you can say the quality. So 100 is like, basically it doesn't do compression for you. And then you can also specify DPI if you're going to print the map. So PNG is also a compressed format, but it does the compression in a different way. So it doesn't lower the quality, but instead it's the way it saves the data. It's more efficient. So you don't really lose quality, and it reduces the size of the image, but not as much as JPEG, because if you really want to make your file a lot small, you should lose something. That's why JPEG makes files quite small. PNG doesn't do that, but then it preserves the quality. So if you will have good enough internet, or like if the speed is not a problem and you still want to have an image that is not super heavy, super large, then PNG is a good balance between quality and size. Yeah, so if you're going with web display, these are good. These are good. Like going with images, such as this. If you want to avoid any form of compression, the compression is going to mess with your data. So if you really need, for a number of reasons. For example, if you want to print, then compression is not a good idea. You want to avoid those compression-based formats. Another thing is that accuracy of data is because they do a bit of resampling, so things a bit change. So if that's really important for you, then you may want to also avoid those formats which use compression. So if you want to avoid those, you can use formats such as BMP or TIFF that do not do compression. So what you get is what you have produced. And so this way you ensure that the image you have produced, the map, is stored in its original form. Very often maps are exported as PDF, and we know PDFs are very convenient, and they're a good balance between file size and quality. They're suitable for many things. So PDFs are easy to share, but also if you want to print it, they work okay. So this is also a common format for exporting your maps. There are also vector formats. It's the same idea of vector versus raster in GIS. With vector, it's different, the whole process. So they are high resolution. They can support animation. It's easy to manipulate in graphics programs. So if you have vector, you take it to some other software, you can easily work with it, change things. With raster, with image, you have limitations. And also, they work well with plotters. So if you're going to print the map with a plotter in very large size, then you probably want to export your map in a vector format rather than compressed or other image format. So this is very practical, quick note on formats. Another thing to think about is fonts. And this is not specific to maybe static maps, but a bit more relevant because in interactive maps we do not really have so much text. You might have a button and the button has a text or very limited, but it's usually in a static map that you have title, you have like a legend with like text. So it's more relevant here. So getting the right font makes map look professional. You're probably familiar with that. Depending on what font you use in your report, in your slide, it can look very different. So the same thing applies for maps. They're crucial for clear communication and aesthetics in your map. Again, some fonts can be hard to read or a bit annoying to read, so you want to keep things look nice, but at the same time clear. So there are two font categories. We have the serif fonts that have small lines, serifs, and at the end of the characters. So there are a number of examples of these fonts and a few common examples from mapping. Again, no one is going to tell you what font exactly you should use. It's a matter of style, what you want to do. But if you are not sure what to use and you want to go by like what is common, these are the common examples for mapping. That comes from the Peterson book. So then we have the sans serif fonts that do not have the serifs, and then again some examples of some of the most commonly used fonts for mapping. So as I said, that means that you have to use this for using your map, but if you're not sure what to use, then it's usually safe to go with the more common one. Then when it comes to fonts, it's important to also think about the size and not just the style. So there are a number of factors you should take into consideration when choosing the font size, but one of them is the visual hierarchy, something we have talked about a lot during this course. But what is it that you want to really bring attention to in your map? So if the title of your map is super important, you want everyone to immediately notice the title, then you might go for a bigger font size for your title because you want to highlight it. So that's one factor to take into account, that the legend of your map is super important. You have a lot of text and you want them to be very readable. Like if you want to highlight it somehow, then that affects your choice of font size. Other than that, the key factor when it comes to choice of font size is the distance of the viewer to the map. So again, depends on where you're presenting your map. So are they going to see it on a screen on their computer, or are you again going to a conference or presenting somewhere and you have a printed poster? If you have a poster, probably whoever is looking at your poster is within 1 or 2 meters distance of your poster. That gives you some idea how big of a font size you should use. So also like who is the audience of your map? If you're making a map specifically, I don't know, for older people who might have a harder time reading a small text, then you take that of course into account. But if you're making a map for kids, then you want to use a font that is a bit like nicer looking for kids. And so this is from the Peterson book. This is just some rough guideline of what font size to use. Again, you don't have to go by this, but if you have no clue what font size to go, this can give you some idea. So depending on the viewing distance, if it is relevant to the map you're producing, then for the body text and the layout titles with two different fonts, there is some like reasonable range of font size you can use for exporting your map. So this is from the Peterson book, which is one of the reading materials for this course, but if you search online, probably you see a lot of information about this. So before we move on to the interactive maps, I have like one slide about animated maps. And it's like I've deliberately put it here between a static and interactive because they're more like, well, it depends on how we implement it. Like in this week's tutorial, we are going to create an animated map. We're going to work with wildfires in Finland. We are going to make an animation showing how it changes over time, how they have happened. And then for that, we have made it interactive. So we will add a slider that can automatically just play, or we can just change it. So animated maps are static, kind of. So because if you think of it, it's just like something like that. This is something we're producing this week in our practical. And it's basically a GIF is a number of images that are being played in a row. So it's a collection of static maps, essentially, unless you find a way to make it interactive. That's it. But yeah, so to many of the things, design methods we talked about in a static map is relevant if you have an animation like this as well. Yeah, so they're similar to static maps, but they incorporate movement and change over time. And I put time in quotations because usually that's what it represents, it's time, but it doesn't have to be. So it can be other things as well. One thing is, for example, a space. So how, if you're visualizing something related to a mountain, how does the distribution of that something change from bottom of the mountain all the way to the peak? So we can think of a number of things that can be shown in an animation, but usually it's the control aspect, and we're going to work with that this week. The idea is to visualize how spatial data evolves or changes. It's particularly useful if you're visualizing something that is dynamic in nature. For example, as I said, this week we are going to work with wildfires in Finland, and that's dynamic. It's not the same every year. This year it might happen in north of Finland, next year it might be somewhere in the east, so it's a dynamic thing. So using such animations can be useful. So there are a number of benefits. As I said, it's dynamic, works with dynamic phenomena, and map extra dimensions. So visualizing time, in a map. Many visualization essentially is quite complex, quite difficult. Animations that provide you with one way of visualizing time in your map. And then engagement, usually these are attractive. So if you're sharing the map on a website or a slide where you can have something animated, then it's usually interesting and intuitive for users. So there are a number of techniques for doing that. You can have sliders, and these are things we're going to practice this week. So you can have sliders, or they can be just animations that you can export as a GIF. So it's just, you don't interact with it, but it is animated. And, So examples, you can think of many examples of things you may want to use this kind of animated map for. Common examples are climate change visualizations. We have seen those a lot. Urban growth, epidemiology, like during COVID time, we saw a lot of these maps, how things are like spreading, how things are changing. So these are powerful ways of visualization. So now we move on to the next part of map, interactive maps. So interactive maps are digital maps that allow users to engage with the data through actions such as zooming, panning, clicking, querying. Well, we have used this kind of maps so much. We are so used to them. These maps are dynamic and provide a more engaging and user-friendly experience compared to static maps. So there are examples of interactive elements that you often see. So very often you have a zoom control on your maps. You can zoom in, zoom out, the areas of interest. You have usually a layer toggle. So for example, in Google Maps, you can choose the satellite image or number of options you can choose from. You often have a search bar that can facilitate quick navigation to specific locations, especially if you do not know exactly where they are. And then pop-ups are also useful. So one of the pop-ups is like either a pop-up, meaning that you will click on it, it stays open, or a tooltip, meaning that if you just hover on the feature, it just shows you something temporarily. But these are quite useful if you have the option of creating an interactive map, because I'm sure this is something you have faced many times, creating maps, but you have so much information that it's hard to put them all in your map. It just gets overcrowded, or you run out of ideas how to visualize them if you want to show many attributes of your data at the same time. So if you have the option of going with interactive maps, a lot of the information can go to the pop-up. You don't overcrowd the map, yet you include the information if it is necessary. So essentially, when creating interactive maps, you can include more. You can have different layers of data. You can have features such as pop-ups. So it allows you to share more through your map. So a number of things that are specific to design of interactive maps. Let's start with that quote that I've seen. If you see sometimes in cartography books, easier, simpler, and friendlier is the way to go with web maps, interactive maps. So web maps should be toasters, no need to log in, read the manual or think too hard. Just put in the ref or address and push down the lever or mouse button, and that's the idea. So especially with maps, we have talked that it's good to stay as simple as possible. You don't want to confuse your users, viewers, and this is especially important for interactive maps. So you want to keep things simple. I'm sure you have had the experience of using some web map where it's hard to find buttons. How do I toggle the layers and where is it? It can be very frustrating. So you want to avoid that. So a number of things to consider in the design of interactive maps is, one thing is the user interface. So you want something that is intuitive and accessible for different users with different range of skills. The elements, if you have buttons, if you have different things, they should be clearly visible. Another thing to think about is the layer management. How are you going to do that? If you're having, for example, a drop-down list of layers that users can choose from, try to be logical with the order. So if there is one layer that you know that 90% of the users will use that layer, then it can be the default or the top of your list. So try to make it as simple as possible. And think about visual hierarchy that we have talked about during this course. Interactive features, as I said, you can use pop-ups, tooltips, whatever you find usable for your data, for your visualization, and search functionality if it is useful for your work. Responsive design, we know that many of us nowadays browse pages, including pages where we have a map, on different devices. So you know how annoying it is to open a website that is not responsive if you want to open it on your phone and it looks bad. And it's particularly annoying and unusable if you have an interactive map. So think about that. Responsiveness is not about only how the map loads on a phone. So it's also about the amount of detail. So the map should be responsive depending on whether you're opening it on a phone or a different size of a screen, or how much detail do you want to have there. And also related to the zoom level. You know that this maps automatically adjust the amount of detail that you have depending on the zoom level. That is something to think about. We're going to talk about that more. Static design, like any other kind of map, you want things to look nice. So the same things we have talked about, colors and visual variables apply here. Data visualization. Again, map projection we have talked about, and it's relevant to any kind of map, but particularly with web maps. We often work with large areas, so projection is something to think about. So very often the projection used is somehow dynamic. So if you are zooming the map over Finland, you want to have a bit of like dynamic projection, depending on what is the zoom level, what is the extent, or not. But depending on how much complexity you want things to consider. And sometimes you want to add other elements, like I said, combination of map and non-map visualizations can be powerful. So in this week's practical, you're going to combine an interactive map with a chart. So you will have, I guess it's also for the wildfires. You have a map of Finland, you have different regions, you visualize what is the number of wildfires in each region, but also you can interact with it. You click on the polygon, there is this pop-up, and then we have a chart showing. So showing all this in a map would be impossible or very impractical. But in an interactive map, you can do that. So, about zoom level. So when it comes to zoom level, one thing is the initial zoom level. So those of you who have created interactive maps, for example, in Python, those of you who have done this, for example, in AutoGIS course, you probably remember that you have to specify what is the initial zoom level, where you want the map to load from initially. And that very much depends on the purpose of the map. So if it is a map that is most of the time used by people of Helsinki, then why would you have your initial zoom level at the word level? You can already start zooming over Helsinki. That is something to think about. Zoom level can range between 0 and 20 street view, and this is by convention. And this is the value, for example, you use when you do this with Python. Usually libraries use this range. As I said, the projection can be dynamic. There are libraries that take care of this, so you do not want to do it manually, but it's good to be aware of that. And again, we have experience with interactive maps. There are different levels of detail you want to be visible at different zoom levels. But it's not only the amount of information, like that you want to appear at certain levels, but also sometimes it's easier to simplify the object. So if the geometry of the object is very complex and you don't want that much complexity at a certain zoom level, so if a river has a lot of curves, it has a lot of details, and when you are very zoomed out, that detail is not necessary. You just want to see the overall path of the thing. So that's something that usually happens in interactive maps, adjusting the level of detail you want. So talking about tools and technologies, so if you want to work with interactive maps and work with zoom level and everything that comes with interactive maps, there are a number of ways to go. But the most convenient way is to go with programming. You get a lot of freedom how to do things. The most natural choice is JavaScript. When it comes to have things interactive, JavaScript is hard to beat that. So there are also other libraries that we'll get back to later. So many of them are JavaScript based, but for those of us who are comfortable with Python, luckily there are Python implementations of some of these. For example, Plotly was to be and Folio that works. They're based on JavaScript, but there are Python implementations. So if you're comfortable with Python, then good news is that you can still stay in Python environment, but benefit from JavaScript work. Then software platforms, basically ArcGIS Online is one way to go. Of course, we want to do things our own way, so we generally avoid these solutions, but anyway, it's available to us. Google Maps API, Mapbox, And even with QGIS, there are a number of plugins. So it's not as elegant as doing it the programming way. But if you really want a quick solution, for example, there is this QGIS plugin, QGIS to Web. It's very simple. It's just install it. It publishes the map for you interactively. If you just want something quick, there are plugins for that in QGIS. Methods and tools for mapping. So during this course, we have seen, especially during the practical sessions, we have seen a wide range of tools that are available to us as a cartographer. Choosing the right tool, you should consider your needs. So what are the project requirements? So it can be a bit confusing. Like, for example, in this course, I don't know how confusing you found it, the fact that you had the possibility of going with Python, QGIS. I even heard from some students who decided to use R or other programming languages. So there are a number of possibilities available to you as a map maker. So what is the best thing for you? A number of things to help you to decide. Project requirements. So what is the level of complexity? So if you really want to make a complex interactive map that is going to work, it's super important you're sharing it with many people. Then you want to go the proper way. Do it with programming language. They have a lot of control over it. Or if you just want to quickly share an interactive map with your colleague, just, I don't know, a colleague who doesn't know GIS or doesn't have any GIS software installed, then you might want to just do it with that QGIS plugin. You just quickly generate some link, share it with your colleague, which you can use the map, and that's it. So it depends on the purpose. You don't have to always overcomplicate things. And then skill level, of course, it depends on what you know, what you are comfortable with. And integration. So it's a thing with working with visualization or anything. So depending on what you want to integrate it with. For example, if you want to create an interactive map that you're going to publish it on your website, you should consider that. Does it work well? For example, in our last week's tutorial, we worked with the Longboard library, those of you who looked at the Python version, for visualizing the big data. It was a very painful process to produce an HTML version of that with the Longboard library. So I wanted to put it to the course's website. It was quite difficult. With Matplotlib, with Folio, we can easily export HTML. But with Longboard, it was very difficult. So if I want to make a map for my website, Longboard may not be my first choice, the Python library. This is something to think about, integration. So there are a number of, this is not a comprehensive list to just give you some idea what tools are available to you as a cartographer. So there are a lot of software that we are very comfortable with. There are graphic design software, like I said, many use Illustrator or the open source equivalents for graphic design, so those are useful. There are online platforms for GIS. But of course, we are geographers. We are the people who are supposed to know how things work. So anyone can essentially use those. So if you want to do things right, we should go more like this way or become very good at software. So yeah, so with programming and scripting, if your job really involves interactive mapping, I would recommend you to go with JavaScript and learn that. But if you just need occasionally some interactive map, Python works good enough. The good thing about Python is that it also can do data analysis, so everything is in just one place. It's nice and neat. And then, there are the strengths and limitations with each of these. And you should see which one works best for you. Another example is Carto CSS, which is related to Carto, so nowadays it's commercial, so it's not as open as the other options you have here, but it comes with a lot of map styling, especially for thematic maps. This DexGL is a very good library. that is originally a JavaScript library, and I have never worked with this myself, but PyDeck is a Python version of it, and I've read good reviews about it. So we have worked with Folium before, and we will work this week on Plotly and Matplotlib, but PyDeck is also one that we consider, especially it's efficient. So if you have very large data and people need to there's a lot of data in the back end, then PyDeck is very efficient. So there are a lot of options you should choose based on. But getting back to one thing I mentioned at the beginning, so this is a simple map that we are very comfortable with using in QGIS, Python, everywhere. So it has all the basic elements. Inset map, we have the legend, we have the elements that we might need. But producing this, it's a matter of choice, a matter of taste. Do you think this looks better than this? I added a bit of visual elements to it. This is what we like to have as an output of the map. It's very hard to achieve, it's not possible in QGIS. But you have to produce the layers and take them to another software where you can work with. For example, we talked about data formats, and the fact that you can export your data in a vector format. And then vector can work in graphic design software. So then you can take your layers to Illustrator or somewhere else and do these kinds of visual work. So if the looks of the map is super important to you, then you should also get good at graphic design. Of course, there are a lot of software for that, but in the first lesson, we also saw that if you're doing things purely in a programming environment like Python, there are also libraries for image processing. So it's not as easy as doing this, for example, in Illustrator, but you can do a lot of things. Okay, I did a lot of talking. Is everything clear? Do you have any questions? If no questions, you can already think about this map and try to figure out what is the difference here. The data is the same, essentially the same map, but it looks very different and tells you a very different message if you just look at it. So what is the difference between these two? Ideas? Which one do you like better?
Well, the right one, the percentage is divided differently.
Yeah. The only thing that is different between these two maps is the classification that is. You have a data, it's showing the proportion of the students in population. It's an old data set. City of Espoo. The only thing that is different is how you have done this depiction. Again, this is probably something, data classification is something I've heard about before, but I saw this problem in many exercises, so I thought I would talk about it. So it's super important. Data classification, you don't immediately think of it as something relevant to visualization because it's a bit mathematical. So you don't think of it as something you need to know as a cartographer, but you actually do. Because it's super important, it can really affect how your map looks like and what information you're conveying. So if you just look at this, what you understand is super different than what you see on the right map. The only difference is that the classification is very different. So the classification should be done properly based on your data distribution. So there is no one method that suits all your needs. It's just you should look at the distribution of your data and see how it works. But this one doesn't work because basically the map is not showing anything. If you just look at it and you're not good at understanding maps, you might just think that, okay, everywhere in Espoo the proportion is super low, then there's just one tiny area here that has a lot of students. This is not the case. Well, of course, that area has more students, but that's not the true picture. So yeah, so that's why it's important to think about data classification, and it's about systematic grouping of data based on one or more attributes. And you want to, when you use a good classification, you will be able to have a map that reflects the patterns, the true patterns in your data, or the useful patterns from your data. And one thing there are a number of things to think about when you choose classification. One important thing and one mistake commonly made to those who are new to cartography or map making is to use classes that are empty or do not have enough value. So that's something you may want to avoid. Another common mistake is to have so many classes. So if you have a huge legend with 20 classes, this kind of map is super difficult for anyone to use and understand. So you should avoid that. Another common mistake is having overlaps in your classes. So very often the end of one class might overlap with the beginning of the next class. So that is a common mistake to make. So avoid that. So we already know about measurement scales and different data, about interval ratios, cyclic data. So depending on what data, what measurement scale you have, that can give you an idea of what is the good classification method to use. You have nominal data, ordinal data, so that's a different thing. There are different approaches how to do this. So what you want to have is homogeneous classes and enough contrast between the classes. So in the first example we saw from Espoo, there was not enough contrast between the classes. So that's why the map looked so much. You want to make sure that you have that. The number of classes, I said, is important. Again, no one can tell you you have to use this number of classes, but as a rough guideline in cartography, the magic number is somewhere around 7, so 7 plus minus 2. So you want to stay within that range. So it's not a good idea to have 20 classes per data. There might be exceptions depending on what you're making the map for, but for general audience, you should just stick to this. So it becomes easy to understand. So humans can perceive 5 without counting, and this is based on research. If you have more, then you constantly have to look at the legend. So it becomes a bit difficult. But there are different classification methods that you can choose from. There's a lot of information here you can go through later, but just showing you some of the examples that are common in GIS. This classification, of course, is not limited to GIS. We have equal interval that we use. Again, choosing this is based on your data distribution. Very often we go with the natural breaks or Jenks method in GIS. It's a good method, but also I guess part of the reason it's super popular is because it's the default one in ArcGIS. We have just used to just clicking. Okay, continuing. Then we have quantile classifications and classifications based on the standard deviation. So this is a visualization of how this would work with different methods. So that's your data. And you essentially put the classes in different places. For example, with equal intervals, you have equal intervals. With quantiles, you have an equal number of points, data points that fall within each of your classes, but the classes can be different. Something based on the breaks, based on distribution of data, like what natural breaks Jenks method does. So it looks at breaks in your data. So if you have a huge gap in the values, then the algorithm decides that, okay, this might be a good place to put create a new class. So this is the same idea, with the same data, different classification, and what we get as the output. So, reminder that classification is super important because you do a good job creating the map, so you don't want your efforts to go wasted. One good other thing is to depending again what the map is for, but you usually want to avoid this kind of numbers because this is hard to read. So you have to do a bit of adjustment. This is much easier. Like round numbers are easier to understand than a lot of details. So you want to also work on the legend to make sure it's understandable. Again, depending on who the map is for. But yeah, that was very quick about classification. Next thing we want to talk about briefly is AI cartography. That's a very relevant thing for us learning cartography, but also those who are like for those of us who are working, researchers or a company, wherever. It's a very topical thing. So let's have a discussion here now. And we don't judge each other. So let's just talk about how we have used AI in this course or any work generally. Just generally speaking related to GIS and particularly cartography. So how have you found AI, large language models, useful to you during this course or anytime making a map? I'm going to go next and reveal my secrets. So
automating mundane tasks. I want to classify some data. Maybe require me to write like statements. That's ChatGPT, for example. And it's a lot of time.
that's a very good tool.
I think if I'm using R, it's like the maps are nice that it produces, but it's very difficult to get the legend in the right position and stuff because of how R does these things in the background. So I think it's very easy to just ask ChatGPT and then get the code and be able to adjust the elements.
Very good use. What else?
Well, I even tried to put the map as a picture, as an input to ChatGPT, and just asked how would GPT make it better, and it gave some insight.
Very useful.
But some of them were.
Used it to modify legend elements, specific shapes and things. In a legend with QGIS, you can customize that. I don't want to write polygon math.
Also with like Python or probably R, working with elements like in Legend can be quite annoying. So it's a very good use. Anything else to add here? Do you have like any vision of AI? AI has been around for a while, but it has entered this domain, public domain, rather recently. Like everyone's talking about it. It's kind of it's not new, but kind of new at the same time. So how do you see AI changing cartography in a few years? Now we already like went through a few items, like a few ideas, like how you can help us make maps. But in 5 years, in 10 years, what do you think would happen, or what do you hope that would happen, making cartography easier, more efficient?
I don't know if it's already possible. It's still learning, so it's probably can be.
You'll be out of job.
Yeah.
I feel like it also leads to everybody doing a little bit of everything, but nobody specializing in things so much anymore. And I think that, I don't know, for me in the course, I've also noticed how it would be really important to work in a team with somebody who, for example, has done some graphic design or something. Because I think a lot of stuff I cannot do, like I might be more specialized in the analysis and then what I want to show, but then there needs to be somebody who knows a lot more about color theory and I cannot do that in AI. I don't think I can do that because it's like value judgment. Yeah, sure. At one point, it might be able to do that, but it might lead, I think, to a lot of maps. I don't know if they're that good.
Yeah. Anything else? Okay, so let's see. Let's go through what I have in the next slide. And in the afternoon, those of you who are joining me for the discussion, we are going to talk more about theory of cartography. We might get back to the topic of AI again. Yeah, AI and cartography, this is based on my personal experience, so probably I agree with many of these things. So it can help you a lot with syntax and code writing, like with not that you would lose your creativity, but like you said, if you're writing something that is very repetitive, working with elements in a legend in your map, and it's very like difficult to move things around, if we can make it a bit easier for you, then why not use it? So that's one place cartography has been helping many people. Lowering the manual work in data preparation, formatting. So that's probably something that many of you have experience with. Like, so for example, like in your code, if you're doing it with Python, you might need dictionary. What you have is lists in Python. So of course you can line it's just a couple of lines of code to just do it, and if you have done it frequently enough, it's not a big task. And then with like something like ChatGPT, you can just easily get the dictionary as output. This kind of like simple data processing and probably more advanced data processing for people. Helping with color choices, like one of you said that you have uploaded your map and you have asked for feedback from ChatGPT. The one thing that is super useful and it works quite well, to my experience at least, is like, for example, this color blindness. Like knowing what colors work exactly, it's like you have to read and see, okay, does this color have some shade of green in it or not? And instead of speculating, again, like trial and see if it works well for you. You can take a picture of your map, ChatGPT or something similar, and it can do a better job of analyzing the color than you probably. It can tell you how it is visible for people who are colorblind. So like you can get some idea. You don't want to purely rely on such tools, but it can give you some idea. So if you're unsure about such things, you can ask AI. Then there are image generators, for example, ChatGPT has its own DALL-E image generator. Nowadays, I just tried this a few days ago. I asked ChatGPT to make me a beautiful world map. And this is what it gives me. For some reason, it just loves arrows. I have a bunch of those. So at this level, it's more of an artistic effort. We can discuss about the artistic part, but it's like there's no value in it like as a map, but I don't know, someone might like to put that on their wall. Piece of art. But this is the level right now, so when it comes to creating maps. And it doesn't work so well, so if you say create a map of, I don't know, Finland or Helsinki, it doesn't do such a good job. Probably because there are a lot of like world maps everywhere, so it has learned from, but not maybe so many specific world maps. And another trend that is very promising, actually I wanted to like include this in our course, like at least we try it at some point. It doesn't work super well, so I will just leave it to you to work with. I don't know, have you tried Dino.world? So there was a big like excitement about it when it was released, but it doesn't work so well yet. They're already trying to sell it. But the idea is to use LLM, these large language models. So you want to get your data from OpenStreetMap. For those of you who have done this in Python or QGIS, it's a number of steps you have to take to fetch your data. So, large language models can understand you in simple words and can convert your simple words into a piece of code that can interact with the API. So this is what Designer.world is trying to do. So you say, okay, I want a map of forests in Finland. It just does a quick search to see what is the data availability, and it just writes the right, in the background it writes the right code to interact with the API and gets the data for you. It has some basic functionality like make the map green. It just changes the color, but it doesn't do a mind-blowing job yet. But it's a very promising thing. So I think there will be in future more of this large language model to map. It just runs the code. What it does is essentially just translating what you're saying in simple words with the code that does the job. So what is the current situation based on what I have seen? And this is not super comprehensive, but AI is already involved in mapping processes, so it's advertised a lot. So if you go to these like online GIS websites like Mapbox and like what else, ArcGIS, they already talk about we have like AI integrated into our processes. But what it is right now is more of the like in the process. It's not really in the cartographic part of things, but a bit with data analysis and some smaller things, but like not in the creative part of cartography. So it's not so much present. So if you search, you see the word, but it's more on the process part, the analysis part, rather than the cartography. So that is something that is probably, like one of you mentioned, is going to probably change in coming years. So, yeah, so I personally see AI being able to enhance the aesthetics at some point. Better examples of like this I know that world, something that works better. And there's already quite a lot of research about applications of AI and ML to map generalization. So like we talked about interactive maps and how you have to have different levels of generalization at different zoom levels. So these are things that AI can really help with, and so on. Okay, so that was it basically what we wanted to talk about, but we have time to go through a number of things. So this is the slide you have seen a few times during this course, and this was the goal of the course. Hopefully we have met the objective somewhat. The idea of this course was to give you some understanding of what makes a good map and then practice a bit through. It was an intensive course, only 4 weeks, so we had limited time. But to see, okay, if this is what an interactive map should look like, how can I do it? So we got to practice it every week. That was the idea. Hopefully we met it, we met the objective somewhat. And now it's time to do the final portfolio. We have published the information on the website already. And for those of you who are coming in the afternoon in the discussion session, we will have more time, so if you have specific questions about things, then we can go through that. But I will just briefly go through the main idea of when did it deliver. The deadline is 16th of June, and you probably want to stick to that deadline because most of us will disappear for a good part of summer. So if you want to get your credits in time, then make sure to submit in time so we have time to do the evaluation before we go on holidays. The idea is to publish your portfolio is like, I will go through the structure. So there's a compilation of your exercises. I will talk more about that later. And then you do a project. The idea is that you publish it because we have talked in this course about different kinds of visualizations, interactive, static. The best platform where you can have all this working is online. They will provide a PDF. How do we want to include an interactive map there? Of course, you can put a link and we can go check it out, but it's most common. So I hope that you can provide a weblog or something like that. But if for whatever, and you don't have to provide any personal information, so you don't have to put your name or ID number or anything like that. What you do is you submit the link to your weblog in Moodle, and then we know who it is. So I don't think there is any worry about privacy. But if for whatever reason you don't want to be online, then you can just talk to us and we can find another solution. But yeah, you can publish it as a weblog, and you know there are a lot of ways to do this. Many of you I know are comfortable already with GitHub pages, so you can produce a page with GitHub. And through University of Helsinki you get these blog pages. Many of you have already used it. I talked to IT before the course started and they said you can get a second one. So if you have used your blog, Helsinki blog for something else, you don't need to close it for this purpose. You can just contact IT and say this is for this course and they will give you a new one. Do it soon enough before they go on So, yeah, so you publish, then it's an individual task, so you cannot do it in groups. So the final portfolio, this is like what you should, a number of things you should take into account in your portfolio. You choose a topic and data set that is of your interest. So we know that geography is such a wide discipline, so there are so many kinds of data sets you can get your hands on and work with. We have put a few examples on the course's website, but I'm sure many of you know many good examples. And here is an opportunity to just play with data and explore it in a fun way. So if there is a data set that interests you, this is a good chance to explore it. So you can choose any data set, but of course choose a data set that has enough to tell. If you just get the population grid from Helsinki, like how much can you talk about it? So get a data set that has more to explore. So that's one thing. And of course in your portfolio, you should say, this is the data, I got it from here. And just a few lines about what the data is about, so we know what it is. So consider your portfolio as a cartographic journey. The idea is that, well, it is related to what we talked about last week. So you have a data set and you want to explore it. So you decide, okay, when looking at this aspect of my data, I should make a chart. Then make a chart. Then explore the chart and say, okay, I see this and this from my chart. To look at another aspect of your data, you may want to put an interactive map. And put an interactive map. So it's a combination of different visualization forms and a bit of text to just make the narrative smooth. And last week our guest lecturer talked about how to tell stories with geospatial data. We try to use what we learned last week to create your narrative. Use a wide range of visualization methods to build your story. I don't want to give you a number like you have to produce 3 maps, 4 maps. If you're really unsure, you can ask us if it is enough. But I would like to leave it to you. Like, how many visualizations and what kind of visualization do you need to efficiently explore? And keep in mind that we have learned a few things during this course. So if we just make a quick map, without considering any of the things we have learned during this course may not be enough. So use what we have learned during this course and choose what is enough. Be organized and structured, so write a nice portfolio, because it's like part of the idea of this course. Cartography, we talked, that it's a form of art. We want to make things understandable, pleasant, so try to make your report pleasant and easy to read and follow. So pay a lot of attention to aesthetics and how things look, text and visualizations, of course. So the structure of the portfolio, there's this compilation part of weekly exercises, so you don't have to reproduce the maps, you will have the maps. Just put them there and write a few lines about how things have worked. So how have your maps evolved, what have you learned, just very simple. The idea is to have everything in one package at the end to see what has been your journey during this course. So you don't have to redo those things, just include them and write a bit of compilation. And then the data. So you choose a data set, write a brief description of the data. Say, okay, I got my data set from here, it's about this, it's from this year, very briefly. And then geospatial narrative, so you, as I said, like what we discussed last week, you tell a story, exploring the data, using different visualizations, and then you have a conclusion part where you provide a concise summary of your discoveries and insights based from your visual exploration. So you have explored the data at the end, you said these are my observations, and you will reflect on your cartographic process. So that's the overall idea of our portfolio. Is it clear, or are there? So you have a bit of open hands. Of course, we have guidelines, but we want to give you a bit of freedom so you can use your creativity without counting how many maps you have produced for the work. So that's the idea of the portfolio. One last thing, so the feedback for the course opens on the last day of the month. And it would be great if you can send us feedback through the form. As I said, this is the first time we are teaching this course, so probably There are things that work well, there are things that probably can be improved. So you can be honest with us and share your suggestions so we can hopefully improve the course for coming years, because this is a course that is going to happen every year. So it would be great to improve it. And that's it. So these are the sources for the slides today. For tutorial, we will publish the information later, but yeah, we're going to create interactive maps. This is actually, we're just going to create interactive maps, and yeah, for the afternoon we have a written material. So if you're coming, I was a bit late with sending a notification, but it was already on Moodle last week. So if you have a time, take a quick look at this paper, and we are going to discuss it. And yeah, hopefully I will see many of you in the afternoon. Yeah, we are a bit early, but I guess we can go for lunch.